Bonjour, merci d'être là avec moi. I was supposed to do the talk in English. I can do the talk in English. That's not an issue. Okay, then I will do the talk in English because what's your native language? Dutch. I can't do any Dutch. Goedemorgen. Okay, thanks to be here for this talk about end-to-end pull request testing on Kubernetes. I'm Nicolas Fränkel. I have more than 2 decades of experience in the IT industry, mainly as a developer, an architect, or whatever, like in technical roles on projects. And lately, I've been a developer advocate, trying to get back to engineering. If you have a job, please ping me. I hope that you will ping me. Okay, so the foundation of this talk is me thinking about a simple engineering use case. Like I am director of engineering, or I'm VP of engineering, or I am whatever of engineering, and I ask my teams to have an end-to-end pull request testing using some cloud provider. That's not amazing engineering. I believe that everybody should do it. Who does it already? End-to-end pull request testing. Nobody. Okay, so I know the reason you are here. And I said, okay, I will try it and see how easy it is, because, I mean, that shouldn't be too hard, right? Took me 85 attempts to get the damn thing working. And I'm not particularly stupid, right? 85 attempts. And I thought, then perhaps I can share what I learned. So first, I'm particularly interested in testing. A couple of years ago, I wrote a book about integration testing. All the technical part is obsolete. The concepts, I think, are still valid. And one of the things that I mention is the book is the closer you are to the target environment, the more confidence you have in your tests. Like in the old times, some of you weren't engineers at the time, you were still in school. I wouldn't dare say some of you hadn't been born, but perhaps, I don't know. Yeah, you seem to be quite young, right? And we wanted to test the persistent layer. So you had a couple of options. One option was you were super rich, your company had a lot of money, and then you spent a lot of money on Oracle licenses, and then you can give every developer like their own schema, and then they would test the persistent layer with the real target database. You had a lot of trust in your test because that was your target environment. But, of course, that wasn't always possible because not all companies can buy lots and lots of Oracle licenses. So the poor man's way to do that was to use an in-memory database that would emulate Oracle. And of course, it was emulation. So you had like less trust. So it was faster, it was cheaper, but you had less trust. So it's always this trade-off that you need to make. But when your target environment is Kubernetes, I believe that you need to test on Kubernetes, otherwise much less trust. Also, I distinguished at the time unit testing and integration testing. And I had this idea that, unit testing was you would test a class, and integration testing, it starts from 2 classes because they need to work with each other, they need to integrate. And I dismissed the idea of Google saying, yeah, there are slow tests and fast tests. Now, with experience, I think there are slow tests and fast tests, and the rest is irrelevant. However you call them is irrelevant. So in this talk, I want to have a couple of components. And of course, I will use specifics, but you can use anything. So I will need an app, of course, otherwise, why? I will use at least an integration test or a slow test. I will have a Kubernetes cluster, and I will have a pipeline that runs the test. As for the specifics, I'm a JVM developer. So I will use a Java app, but you can use anything. In a workshop that I've written, I used Python because, again, it's completely the same. I have a Postgres database because Postgres nowadays does everything. I have REST endpoints because I want to test doing integration tests, so I need to offer some ways to actually test the stuff. And my integration test, because I will have a single one, it's a demo, it's a talk, it's not a full-fledged integration testing harness, is I will get all the products using the get endpoint. I will add a new product. I will get all products again, and I'm checking that there is one more product in the second query than in the first query. I mean, it's nothing mind-blowing, like full integration testing. I will target Google Kubernetes engine, not because it's the most amazing in the world, because it's the one I know. So, suits me. And I will use GitHub and GitHub Action, because they are super widespread, actually. I'm particularly a fan of GitHub Actions themselves. But again, you could use GitLab, you can use anything. So this is my implementation, but you can replace everything. The concepts should be the same. There is one very important decision at the beginning, something that has impact on all the rest, is where do we create the Kubernetes clusters? Because on one side, we could say, oh, we will create the Kubernetes cluster on the GK side, upfront. And so every pull request can use it, but then you run the risk of collision. So you have namespaces, right? So you say, oh, I will use namespaces. Correct, but not all Kubernetes objects are namespaced. As soon as you use CRDs, for example, and one of the pull requests might decide, okay, I will upgrade the CRDs version, then you will have an issue because they are not constrained to the namespace. They are cluster-wide. So it's great because it will make the test very fast, but you run the risk of collision. The complete opposite side of the spectrum is, okay, I will create the Kubernetes cluster at every run, and it's fully possible. The thing is, on GKE, it takes between 5 and 7 minutes to create a full-fledged cluster. And when I say full-fledged, I say minimal setup, like one node that just works in one zone, no availability, no nothing. Very isolated, but it will add that time to every one of your pipeline. Is that a good idea? I don't know, it depends on your context. But if your pipeline runs normally on 5 minutes, and you add 5 more minutes, you just doubled the time for feedback, which is not that great. If it takes 2 hours, then that's fine, you don't care. 5 minutes is not a lot. But if it's fast, then it will really slow you down. So I think that's a good trade-off. Would be to create the control plane, to create the cluster upfront, but in order to avoid collisions, I will create a virtual cluster. There are there are a couple of technologies to do that. I will use something called vCluster that lets you create a virtual cluster inside of your cluster. It takes time, but it takes much less time than a real cluster. You don't have problem of CRDs or port conflict or anything. It's fully isolated. So it solves the isolation part, and on the opposite side, I will have the control plane running all the time, which costs a bit more money, but it's about $80 per month for a very basic control plane. So I think this is worth it. Again, depends what your context is. but for most contexts, it should be a good trade-off. In this talk, I can talk about a lot of stuff, but I will try to constrain the stuff to what is interested to most people. So I won't tell you about like the GKE setup, because if you run on Amazon, you don't care. The app, I will keep it to a minimum. I will detail a bit GitHub workflow, because I think a lot of us are using it. Who is using GitHub workflows, please? Not that many. Wow. What are you using? Sorry, again? Azure DevOps. Okay. GitLab, anybody? Wow, there are more people running GitLab than GitHub. You should have told me before. I should have redone my talk. Again, I will show you how to do it with GitHub, and you can do the same with GitLab. The thing is, I'm using a lot of actions because I'm super lazy, and basically I don't want to script everything, and GitHub Actions, I really like them. I love GitLab, but GitHub Actions are very good if you want to reuse stuff. So the overview is the following. First, I will build the container. Then I will push the image to the GitHub container registry. I will create the virtual cluster in the existing GKE. I will have the GKE already set up. I will deploy the container inside of the virtual cluster, and I will run the test. That looks like basic engineering, right? 85 attempts. Remember, 85. OK, I start my workflow. I give it a name. Ooh, amazing. And depending on your Git strategy, I will say, I will run it when there is a pull request on master, on main, when on this branch develop, on whatever, I don't care. You have your own flow, and you put it. And very important, especially at the beginning, not only for demos, but at the beginning, you should be able to click on the UI to run the workflow. Because, again, at the beginning, there will be a lot of failing pieces. So now I create my job. I will build it. So I give it a related name. I will put everything in one single workflow. If you want, you can reuse some of them to have like common patterns, but here I will stay very simple. You need to have a couple of additional permissions because, again, you will be pushing to the GitHub container registry. Depending how much you want to be able to customize the workflow, you need to have environment variables. So here I will only have two. Hey, suppose I want to change the registry, so I have another domain. And on GitHub, the time you actually keep the image is very important because it takes space and it takes money. But you still want to keep it in case you need to download it to check what's happening because something failed. So you could say, oh, I keep it for 1 day, and then afterwards, it's gone. First step, check out the repo. Amazing. Second step, I need to log in into the repository because I will need to push to the repository. This is how you do it. There is something called a login action. It works perfectly well. Environment variables are very important. Yes, I found it. Oof. So registry is the one I created in the environment variables. You don't need it if it's not necessary, but I like to have it. The GitHub actor is something that is provided out of the box. The secrets.github token is also out of the box. So I'm reusing stuff that I already have. I will create the image now. But now comes the first problem. When you are in production, you create the image and you tag with the version, using semantic versioning, using whatever you want. And that's perfectly fine. But here, we will run into collision because two PRs might be on the same snapshot version. So what scheme should we use? What would be the unique identifier that we should use for the tag? Who has an ID? Yes. Sorry? The pull request ID. On the first attempt, the pull request ID is a very good ID. But what if the workflow of the pull request fails and you need to restart it manually? Collision. Yes. Sorry? The date. Yes, sure. Date, no collision, unless you really, really want to be a fun person. But in that case, how can we correlate it to what we run? Yeah, you need then, if something fails, you need to do some archaeology, which I don't like because I'm lazy by default. So whatever system you are using, there is something that calls the run ID. And a workflow, if you run it multiple times, will have different run IDs. GitLab, Azure DevOps, whatever, they all have a unique ID. Use it. And then you are sure that you have a unique ID provided by your cloud, or perhaps your own system, I don't know. And then it's very easy to correlate. Great. That seems to be good. So there is this metadata action. It will create the label. It will create the tag. We are overriding the tag with our GitHub run ID. Amazing. Now the only thing that we need to do is to build and push it. So here I assume that you have a Docker file. So I am inside, I'm in the same context, in the same directory structure as the Docker file. If you are using GitHub, you might see that here I'm using steps.meta. Why meta? Because that's the ID of the previous step. So basically here, I just provide data in the context of the pipeline, and then on the next step, I'm using it. So as I mentioned, I'm overriding the tags, the labels. I use the default one that were created by the action, but of course, if you want to have additional data or to override the labels as well, you can do it. And then I push. Amazing. So for something simple, that's not that simple already, but we managed it. Next step is we want to use it on GKE. And I told you I don't want to delve too much into the details, but I still need to tell you a bit about the GKE authentication model. Spoiler, it's not super fun. So the first is you have a service account. Service account, it's normal, right? Lots of components have service account. It's an ID that is tied to a technical component and not to a physical person. Kubernetes has service accounts, okay. Now you have the workload identity provider, which manages identities for different external identity provider. And you have the workload identity provider pool that configure one of them, which gives out this simple model, right? You have the service account. It has different roles. Roles have different permissions. Service account uses the workload identity pool, which uses one or more identity pool provider, and then you have an external identity provider, in our case, GitHub. We are using OpenID Connect. Well, when I say we, Google is using OpenID Connect. And it's a game of matching attributes between what GitHub will actually provide and what Google actually requires. So the Google subject on GitHub is called assertion sub. Now, this one is easy, this one is easy, this one is easy. And since 1 year, about 1 year, I think you didn't have this requirement before, but now you need to have a condition. can be a stupid condition, but you need to have a condition. In this case, this is actually a very stupid condition because I said that the actor, so the person actually running the workflow, the pipeline, needs to be me, my GitHub account. Which is stupid because probably a lot of different developers will use this workflow, and they will need to be using it as well. So this is an example of what not to do. Probably what you should do is to have something regarding the repository or the repository owner, or even better, to have different conditions with like or a, like Boolean logic. So this is set up upfront. Now, in the workflow, hold your horses, you have this very easy URL to provide. Project number. Yeah, on Google, on GCP, you have the project ID, which is actually not a number, which is a string, and the project number. The project number, you need to find it out. Have fun. I leave you the surprise because it's fun. Then you need to set the workload identity provider name, the workload identity pool provider name. And the service account is easy, is actually just the email of the service account. So at this point in the workflow, in the GitHub workflow, we are authenticated on GCP. But we don't want to use GCP at large. We want to use our GKE cluster that we created upfront. Because we will be using kubectl, probably you need to set configuration parameters to get the kubeconfig. Again, nice action. You tell it the cluster name that you created and its location. And it will download and put in the right location the kubeconfig. At this point, I really advise you to run it. There is a huge chance it doesn't work. So now, you just run a simple kubectl get pod in all namespaces if you want. And if it works, you should see something like this. If you manage it on the first try, write me an email or ping me, I want a screenshot, and I trust you. But you are very good and very smart, so I hope you will manage it. Plus, you have all these examples here. I mentioned I will be using vCluster to isolate my clusters, to have really different virtual clusters. So I install vCluster. It's like super easy. Now I need to create a virtual cluster, and I will run into the same problem I had with the image. Is I need to create virtual clusters that are different from each other. What ID should I use? What discriminant should I use to be sure that everyone will create a different virtual cluster? Nobody? It's written. It's the same as before. I mean, we are lazy people. If it works once, it will work twice. So we create the virtual cluster, and we pass the GitHub run ID as the discriminant so we don't run into trouble. From the GKE instance, we will actually deploy the workloads, meaning that we need access from GCP GKE to the GitHub container registry. We need to authenticate ourselves, meaning we need to create a secret for that. You pass the required parameters, and you run kubectl create secret Docker registry, GitHub Docker registry. I think one of them, I don't remember which one, is set in stone. The other, you can set the name. I always forget. I think the Docker registry is set in stone, and the GitHub Docker registry is the name I choose to give it. Note here that I am doing a dry run. I put it into YAML, and I pipe it to kubectl apply f. Why don't I just create the secret directly? Who has a clue? In this case, it might not be really necessary, but it's a nice trick that I found. Now I'm applying it everywhere. If the secret already exists, you will have an error if you just try to apply it directly. Whereas here, I will override it, and basically, in case it doesn't exist, it will be good. In case it exists, it will override it. It will be good too. Super trick. I create additional secrets and config maps because, as I mentioned, I want to test using a database. It will be a full-fledged integration test. So here, I'm using Postgres. I'm very stupid. I'm creating a config map. I can't create secrets, but normally, it shouldn't be an issue because there shouldn't be any sensitive data, especially in a testing workflow. You can use secrets if it really hurts you. Up to you. It will be used exactly the same. Depending on your exact requirements, you can install whatever you need. Here, I'm using only Postgres. I will install the Helm chart from Postgres. I'm done. Now comes the real problem. I gave the image a tag that depended on the workflow run ID, the GitHub run ID. So it will change every time. But my manifest, I write it once. So I need a way to say, OK, I will update the manifest with this GitHub run ID. How shall I do it? There are two ways to do that. If you have 10 years or more of sysadmin experience, there is this tool called SED. You change a string, right? It works perfectly well. If you are a cloud-native DevOps, you use the tools that Kubernetes provides you, which is customize. Both work. If it's to change a single string, sed works, and I would use it. As soon as you need to change in different places, use customize. I provide you the two ways here. So on the first customized way, you apply K instead of applying F. I'm too fast. No, I'm too fast. And here, I provide the customized snippet. So basically, I'm changing the image and I add this tag here. It looks super nice, especially if you know what you are doing. And of course, the quick and dirty way is less nice, but works exactly the same. I think this is simpler if you have one thing to change. Again, multiple things, use customize. Now comes the fun part. Everything is deployed normally. You have the database, you have your app. Now I need the integration test. So basically, I need to have the URL of my app that runs inside GCP, inside my virtual cluster, exposed to the outside world, in this case, GitHub. How do I expose a URL to the outside world? Through a service. And here I'm using GCP, so I will use a service of type load balancer. Correct? Wow, that's a lot of feedback. Correct? You feel a trap, right? Because you saw the bomb. Yeah, you are smart. Indeed, it's not correct. If you do this, what will happen is your test will fail every time. Because Google, GCP, like any other cloud provider, will need time to actually assign you an IP that you can call. And meanwhile, your test is running and crashing. 85 attempts. So what can you do? You can do the very, very, very boring stuff, which is called bash, and actually loop. Oh, I don't have an IP. Wait 5 seconds. Oh, I don't have an IP. Oh, wait 5 seconds. Until either you run into a timeout. So in general, it takes me 10 or 15 seconds to get it working. Very, very important. You write it down in the log. Very important. You know, when I started doing JavaScript 20 years ago, that was our way of debugging. If you don't have monitoring or anything, do it. It works. Good. And now, what's happening? So now the GitHub workflow is deploying the container, the virtual cluster schedules them, and we launch. We have the service, but the pods are not ready either. That sucks. Because the pods, the app, depends on the Postgres pods, and the Postgres pods initializes some stuff, and it takes 10, 15 seconds already. So what shall we do? 2 ways. So that was my go-to method, and then told me, oh, you are not doing cloud native, you are an idiot. And I say, okay, so I will show you both methods. I'm using a container that actually, whose sole purpose is to wait. This container waits until something happens. It's called wait for X. You can wait for a lot of different things. It's very, very useful. And here I'm using wait for X HTTP. I set the base URL. And of course, I need to have an endpoint to my application that says, hey, yeah, I'm good. You can call me. You can have timeout. You can have whatever you want. So this is the dumb, idiot way of doing things that works. Or if you are cloud native DevOps, then you use kubectl wait. Could be even better because I don't need to download another image. Both work. Basically, it works also for this, kubectl wait, until you've got the load balancer. But I like to show that, yeah, I'm not smarter than anybody, and, well, at least it works. Like continuous improvement all the time. And now the test works. It's amazing. But we forgot something. We forgot to clean up. Otherwise, if we don't clean up, you will have a lot of virtual clusters, and at the end, your small instance of GCP then will of GKE, sorry, will actually be full, and you won't be able to run more tests. So we delete the cluster. Good, right? We delete the no. You feel there is a trap because it's written the naive approach. Sorry again? In case of failure. Exactly. In case of failure, it doesn't work. There is a bomb. So what do you do? And that's where GitHub is not that great, because the instruction is always, is if always. So semantically speaking, it's not amazing. But it makes sense. So normally, a workflow, a GitHub workflow, a GitHub pipeline runs all the steps in order, unless you have made some black magic to run in parallel or whatever, but basically they run in order. And if they run to completion, that's very nice. If they encounter a failure in one step, they stop the pipeline, and they return you like a failure because, well, you failed, so why continue? It fails fast. It's not a bad default. It's actually normal. But in this case, we want to clean up the virtual cluster. Otherwise, again, they will pile up and fill up the GKE. So we need to have if always. Does it work? Does it work? Yes, you are confident. That's good. In that case, there was still a trap. Because what happens if the failure happens before we created the virtual cluster? You will actually try to delete something that was not here, and you will end up in a failure, which will be a double failure, and it will be weird. And so, be ready for the syntax of that crap. If always and vcluster, which was the name I gave when I created the cluster, conclusion equals success. So this should work in every case. And now I have more than a lot of time for a demo. And I can show you a bit more improvements. So first, just that we agree, I just ran it 1 hour ago. It's 1 hour ago. So even if it fails now, I have proof that it works. Just to conjure the demo gods. Okay, as I mentioned, I should be able to do it manually, especially in the first few iterations, where basically there is a lot of chance that it doesn't work. See? That's the demo that doesn't work. That's the demo where I actually changed the project name. So I knew exactly what I did, right? And I still failed because of some GCP configuration. This, I forgot to set up the cluster because I tear it down every time, and I say, oh, I will run it. I forgot to set up the cluster. Anyway, let's run the workflow. And then I can show you what I'm running. This is just a bit more advanced than what I've shown you. The first thing is I created a bit more environment variables. Again, not really necessary. Here, did you know that you can actually create containers in your GitHub workflow? You can run containers in your GitHub workflow. What's the point? The point is, if something doesn't work in my stupid GitHub workflow, there is no chance it will work on Kubernetes. So I want to fail fast. Because, again, I won't deploy something on GCP. It saves me a few cents, or even dollars. So here, I have a test, what I call a unit test, which is not unit at all. It's just a test that runs inside the Google workflow. Here is just the setup of the database. I can show you afterwards the test itself. The steps that I've shown you. I would also advise you, whatever platform you are using, to set up the cache, so you don't download the dependencies every time. It will run much, much faster. You can also cache the build artifacts. If something failed, it was not the problem of the jar, then it's better to have the jar already running. So here I'm running the unit test. Notice the double quotes, because I will use localhost, which basically will be the Postgres instance running in the GitHub workflow. Okay? I authenticate on Google Cloud that I have shown you. I will set the GKE credentials. I edit the image tag with the GitHub run ID using customize, sorry. I install the virtual cluster, I create the virtual cluster. I forgot. I need to connect to the virtual cluster. Very important, because in order to be fully isolated, I need to be inside the virtual cluster, so I connect to the virtual cluster. I schedule the Postgres through Helm. I set up my build. So here, what I'm doing is I'm trying to be smart and actually to set up the stuff that might take time. For example, scheduling Postgres so that I don't run into like timeout afterwards. So it's like of parallelizing. So it's imperative saying, hey, GK, like install Postgres with Helm, and here I'm doing my stuff on my side. I set up Docker, as I mentioned. I get the metadata, I build and push. I set the config map. I have the Docker registry secrets. I deploy the customized manifest, the one that I applied before because I already have the GitHub run ID. I get the load balancer. And finally, I run the integration test, and I delete the virtual cluster. And now, ladies and gentlemen, let's see how it went. Nothing. It's strange. I don't have internet, perhaps. Oh, no, it's running. But I still have a very bad internet. That's the fun of testing with the clouds. Yes. So it's running for already 3 minutes. Let's see where it is. Sorry for the lag. I'm using my phone, though. Oh, no! I'm using the Wi-Fi. Let's try this. Let's see if my phone is better than the Wi-Fi. Yes, much better. Oof, amazingly better. So, hey, I'm already deleting the virtual cluster. So it took about 5 minutes something, and I'm already deleting the cluster, doing like the post steps of everything. And normally, test on PR is green. And you are lucky because we have time for questions. Before questions, I have one slide, perhaps two. First, this is a demo, so I already have a couple of ideas to improve it, but you, as engineers, you can already approve it. I'm using Ubuntu latest as my base GitHub workflow image. Remember? Should I show it again? This is a really bad idea. You don't want to run latest ever, because it might introduce something that breaks your build for the wrong reason. So never, ever use latest. Use either version, which, again, also not great because they push versions. They don't care. If you are serious, you use SHA-1. Okay? And Ubuntu is a big image. Perhaps you want to run smaller image. You don't need everything that Ubuntu provides you. So use the right image for your needs. Probably it's not this one. And cache. Cache. If you have workflows, if you have pipeline, cache. You don't want to download the dependencies at every run if you didn't change them. You don't want to rebuild the artifacts and push it again if you didn't change it. So cache as much as possible. Here it's a demo, so I didn't check if it was really, the cache was really used in the best way. Thanks for your attention. You can follow me on Mastodon. You can follow me on Blue Sky. If you are still using Twitter, sorry for you, you can still follow me there. If you prefer to read about it, I have a 3-part blog series here on my blog. And if you want to see the code, everything is on GitHub. It's hidden behind a bit.ly link, so I can see how many people are actually opening the GitHub repo, and generally 1 or 2, but it's fine. It's up to you. It's available to you. And thanks a lot. And yeah, 5 minutes for questions. Yes?
So thanks for the presentation first. So how would you handle when the tests are failing and you want to investigate the running container, for example, what happened? So how would you keep that up, or how do you extract information?
Yeah, that's what I did. Actually, when I told you about 85 attempts, at first, I didn't clean up the virtual clusters. I kept them running, and I logged into them, and I say, what the hell is happening? And yeah, it helps you debug. So the cleanup phase is when you have a well-oiled machine that normally you shouldn't have any issues, just like also the time that you keep the image on the registry, depending on how mature your organization is. It can be short, it can be a bit longer, it can be forever. It's up to you. You can have also a batch that removes them. It's up to you. But yeah, in the first few iterations, I really kept the virtual cluster running because I wanted to see what's happening and why is it failing and whatever. Good question. Other questions? No question? No problem. I will stay until tomorrow, so if you are too shy to ask the question now, just find me in the conference. Thanks a lot.